Before going into detail in the study of the case of how we receive the satellite TV signals at home, let me just briefly give you some data about the satellite industry and some familiar names for you. Well, on the first line you see the NASA and ESA. Those are the American and the European space agencies, and this is really a very valuable source of information. On the second, you have the first three important satellites. So what we are talking about, it all began in 1957. The Sputnik was just a beacon in space. And then shortly afterwards, two American satellites were launched. First one was Telstar, it was a low orbit communication satellite, and Syncom, that was placed on the geostationary orbit. And this is where we can say that the telecom and TV broadcasting from space began. One of the biggest hits of the Syncom satellites was to broadcast the first TV images from the Tokyo Olympic Games. And telecom development has always been close in innovation to the Olympic Games. While the remaining names are all familiar to you, the shuttle, also the Intelsat and Eutelsat, that are the worldwide communication satellite networks, and some regional or some different names in there. We are very familiar with meteorological satellites, and also we use location through GPS, receiving GPS signals, and this is more or less a list of some of the relevant names in this business. The main civil applications are listed there, and the most important for us today in this class is just talking about television. And we have a broad range now of video services, and there are two basic points to consider. One is we broadcast to a large audience, that's one situation. The other one is to use the satellite just to send information from one place to another. For instance, if you see retransmission, for instance, of a sportive event or something, elections, something that is happening in a certain place, those images have to be sent to the studio and then broadcast. And satellites are very frequently used for this purpose too. All the others are quite familiar to us. Location, meteorology, Earth exploration, data links for internet, voice communications, all of them are really frequently using satellites. And those satellites, in a broad sense, have different services that are classified by the International Telecommunication Union. This is the regulatory body from the United Nations, and they try to make all the services compatible all over the world. And this is just a list of the services as are defined by ITU. To us today, we will be just talking about broadcasting. It's this third line here. And broadcasting satellites are of the same type, and sometimes they are used very connectedly to the fixed or telephone, let's say, satellite services. So the first and the third line in this list are really more or less the same kind of satellites. There are other services. One that in the future is going to grow a lot is the one that satellites will help mobile networks, and this could be certainly not only on land but also on sea and on the air. And the remaining part of the list is just the list of services. Each one has its peculiarities, but they are really now very well defined, and most of them are really frequently used. And regarding those satellites, they are placed in very different orbits. The most crowded one is the low Earth orbit, the one that is closer to us. And normally they are described as LEO orbits, and let's say the distance to the ground is around at the most 2,000 kilometers. But most of the satellites are placed around from 400, 500 kilometers away. And in this case, there you can see some of the satellites that are in this orbit, but there's a particular orbit that is of interest, and it's the one that goes through the poles, because then the satellite is orbiting on a plane, and as the Earth rotates, they, at the end, after a few passes, they will cover the surface of the Earth, the whole surface of the Earth. And this is normally used for either Earth observation, meteorological, reconnaissance satellites. This is one of the most interesting low Earth orbits in use today. Then we have the medium Earth orbits. Those go from 5,000, let's say, those are rough numbers, but that's typical numbers, to 20,000 kilometers. And that's the orbit used by GPS, by the location satellites. Galileo will go into this orbit too. And the third and the important one for us today is the geostationary orbit. This is a very peculiar orbit because it's on the equator and the satellites are rotating at the same time than the Earth, so they stay as fixed in space, and we can really point the antenna and we don't have to track the satellite as happens with the other orbits. Here the communication satellites, and you have there the Intelsat, all maritime meteosats that are all in this orbit. Just a couple of other names regarding orbits. One is the Molnia, that's the Russian name, and it relates to an orbit that was and is frequently used by Russian satellites because we have one problem with geosatellites. Since they are on the equator, the coverage at high latitudes is very poor. So one way they solved this problem was by using very highly elliptic orbits where the satellite will go up to 40,000 kilometers and then come down. But while it was going up to the apogee, then for a long time it will just look as almost a stable satellite. And they had many hours of coverage in that region. And just to finish on this list, they are, in the case of two bodies, could be the Sun and the Earth, or the Earth and the Moon, or any other planets and its moon. There are points where the gravitational forces of the two bodies, let's say, that compensate each other. So they define points where a spacecraft could be placed in a stable position with respect to the two bodies. They are known as Lagrangian points, and they are up to 4 points depending on the situation. But here you just have 2 points that are in use by satellites. In the Sun-Earth, this is the first Lagrangian point. For instance, the SOHO satellite was placed in this case. And the second point, this is the Gala Space Observatory that is just looking for planets. And those are interesting points, and maybe you will hear about them. But for our purposes, we are going to talk about the geo orbit, and this is going to be the most important for us today. We have regulators that assign the spectrum or the frequency bands we can use. And depending on the services, those bands are different. On the first number here, you have the uplink frequency, that's from the Earth station to the satellite. The second number is from the satellite down to Earth. Today we are going to be talking about broadcasting satellites that they were assigned to broadcast around 12 gigahertz, but since those satellites are also using fixed band allocations, then 11 gigahertz is also used, and this is what you're going to see in those satellites. The uplink for those satellites is at 14 gigahertz. So the ground station sends the TV signal at around 14 gigahertz, and the satellite broadcasts to the users at 11, 12 gigahertz. This band of frequencies is denoted as KU band. So here you have also the names of the bands. The names come from the old radar times, but they are still frequently used in satellite business. So we are going to talk about broadcasting satellites in detail.